Let us take some more examples of Leibniz theorem. If y equal to sine of m times sine inverse x, then prove that 1 minus x square y n plus 2 minus 2n plus 1 x y n plus 1 plus m square minus n square yn equal to 0. Now y equal to sine of m times sine inverse x. Now let us differentiate because we need yn plus 2, so we need to differentiate 2 times, and then after we differentiate n times by using Leibniz here. So if we differentiate this, we have y1, derivative of sine is cosine of m sine inverse x, and derivative of m sine inverse x is m over root 1 minus x square. So we have a root of 1 minus x square y1 equal to m into cosine of m sine inverse x. Now let us do squaring. So if we take the squaring, we have 1 minus x square y1 square equal to m square cosine square m sine inverse x. So 1 minus x square y1 square equal to m square. We can write cosine square theta as 1 minus sine square theta. So 1 minus sine square m sine inverse x. But sine m sine inverse x is y. So this is 1 minus x square y1 square equal to m square into 1 minus y square. Now we differentiate again. So again differentiate, we get 1 minus x square, product rule we need to apply. Derivative of y1 square is 2 y1, and then the derivative of y1 is y2 plus y1 square, and derivative of 1 minus x square is minus 2x equal to m square. This derivative of y square is minus 2y, and derivative of y is y1. Now see here, everywhere we have 2 and y1, 2 and y1. So that can be taken out. So 1 minus x square y2 minus x y1 is equal to minus m square and y. 2y1 we have taken out from every term. So now we can have the nth derivative. So differentiate n times by Leibniz theorem. Differentiate n times by Leibniz theorem. So now here two terms. So let us take the derivative of n times of this term. This we can consider as u, this we can consider as v. So this is y n plus 2 and 1 minus x square as it is, plus nc1 n, decrease one derivative, so yn plus 1. Derivative of 1 minus x square is minus 2x plus n minus 1 by 2. One decrease derivative here yn plus 1 less, so that will be yn, and derivative of minus 2x is minus 2. And next term will become 0. So for 1 minus x square y2, this is are the three terms. Now for x into y1, we apply Leibniz theorem this also. So here y1 you can consider u, this we can consider as v. So minus x yn plus 1, n time derivative of y1. Then plus n, but sign is negative here. So we use sign minus nc1 is n. This is yn, less derivative of this, and derivative of x is 1. So that's over. And minus m square, derivative of n times of y is yn. And now simplify this. These two cancel, negative sign will be there. So here we have 1 minus x square yn plus 2. Now here we have yn plus 1 and x. Here also x and yn plus 1. So x is there, yn plus 1 is there, negative sign is there. So negative sign x yn plus 1. Negative sign x yn plus 1. So here we have 2n. And here we have 1 plus. Now this negative sign consider. So yn is there, yn here, yn here, yn here. So this is a negative sign. So minus n square, minus minus plus n, then minus n and plus m square yn equal to 0. So this cancel, and m square minus n square, yes. So this is the answer. So therefore 1 minus x square yn plus 2 minus 2n plus 1 xyn plus 1 plus m square minus n square yn equal to 0. So that is the way we can solve the example. Next, let us take one more example. If y equal to x square minus 1 power n, then prove that x square minus 1 in plus 2 plus 2x yn plus 1 minus n plus 1 yn equal to 0. So y equal to x square minus 1 power n. So let us take the derivative. So differentiate. We have y1 equal to n x square minus 1 power n minus 1. And then derivative of x square minus 1 is 2x. So this we can write as 2 n x, then x square minus 1 power n divided by x square minus 1 power n minus 1. So power n and here. So this we can take it here. So therefore x square minus 1 into y1 equal to 2nx, and then x square minus 1 power n is y. So that is 2nxy. Now differentiate again. So we have x square minus 1 y2 plus y1 into 2x is equal to, now here also product rule, 2n, derivative of x is 1 and y, plus 2nx, and derivative of y is y1. Okay, it will simplify. This is x square minus 1 y2. This is 2xy1, 2nxy1. So this we can take it on this side. So plus 2, then xy1, 2xy1. So this is 1 here, 2xy1. So minus n here, and is equal to 2ny. So now we can differentiate n times by using Leibniz theorem. So differentiate n times by using Leibniz theorem. So here product rule, n time derivative, this we can consider as u, this we can consider as v. So x square minus 1 yn plus 2 plus n times yn plus 1, derivative of x square minus 1 is 2x, plus n minus 1 by 2 factorial yn, and derivative of 2x is 2. Now this plus 2 into 1 minus x yn plus 1. So this is u and this is v, plus 2 1 minus n. Now nc1 is n, derivative 1 less, so that is yn, and derivative of x is 1, is equal to derivative of 2ny, n times is 2n yn. And now we can just simplify. So this is equal to x square minus 1 yn plus 2. Now yn plus 1 term, 1 is here, one is here, and other is here. Okay, so x yn plus 1, 2 is also there. So 2 x yn plus 1, 2x yn plus 1. Here we have n, and here we have 2x yn plus 1, so 1 minus n. Then yn term. So yn term is here. If 2 to cancel, yn term is also here and also here. So plus nyn, nyn, everywhere is there. So n and yn. So here we have n minus 1. Nyn. So here we have plus 2 minus 2n. And here on this side, nyn. So minus 2 and equal to 0. So this 2 and 2 will be getting cancelled. This n and minus 2n is n minus 2n is minus n. And here n. So that will be and this minus 1 is also there. So simplification of this is minus n minus 2n is minus n minus 1. So if you take minus sign outside, it will be minus n plus 1. So this is equal to x square minus 1 by n plus 2 plus 2. Now see n and n cancel. So 2x yn plus 1. Then the sign is minus here. So minus n is there. N plus 1 and yn equal to 0. So last step you need to just little simplify. So in the next video we shall take some more examples. Thank you.